So in some of my past videos, I went through how to manage single step, two-step, and equations with brackets. So all of those. So if you haven't tried those yet, you may want to take a look at those to prepare for today's lesson. In some questions, you're going to actually have variable terms on each side of that equal sign. So in this case, I have a 5x over here, and I have a 2x over on the other side of the equal sign. Right? I also have constant terms that are not both on the same side. So, how are we going to deal with that? Well, it looks like I'm going to need to find a way to combine my variable terms together and then combine my constant terms together. But in order to do that, what I want to be able to do first is to make sure that they're on the same side of the equal sign before I combine them. So that is the strategy that I want you to do. So a strategy for solving equations like this is to move the variable terms to one side and the constant terms to the other side, and then finally add any like terms that you see. Now, some people will say, well, does it really matter? Do the x's need to go on the left side and the constants on the other? It doesn't matter. That's the good news. It's just that both the terms that are like terms need to be on the same side of the equation, same side of the equal sign, in order to be able to combine them properly. So let's go through a few examples. So in this particular case, I want to look carefully and identify where my equal sign is. Here's my equal sign, and I'm seeing it on the right-hand side. I only have the 9. But when I look really carefully at the left-hand side, I can see that I have the 2x and the 6x that are both on the same side of that equation. Well, those are like terms, and before I proceed any further, I really should simplify that. So let me work you through this question. Okay, so I see that I have 2x, and then I'm adding 6 more x. Really, if I wanted to, I could group those together in another step. I think we're pretty good at this, but I'll write it down anyway. So 2x plus 6x, those are there together, right? So now I have the 9 on my other side of the equation, and so this -7 needs to be combined with it. So I need to move it to the other side of that equation and change the sign. So don't forget that the same rules that we've been learning all along still apply here. So 2x plus 6x gives me 8x in total. 9 plus 7 will give me 16, right? And so now I've simplified this enough so that I'm ready to solve. So I've got my 8x, and I want to get the x isolated, so I divide out by 8. Whatever I do to one side of my equation, I want to do to the other. And so that will give me an answer that is x equals 2. And if I were to substitute in x equals 2 into that original equation, I should find that my left side will equal my right side if I've done it properly. Okay, let's skip to another equation and show you something that looks just a little bit different. I'm going to hop back to the last step right here. And so when I look at this is actually the same problem as we just saw. It just looks a little bit different. So you're going to see that, once I get past the first step, the solution will be very much as what we just saw. That'll allow us to focus on the process and what to do when we are in certain given situations. So first of all, I can see here that I have a 2x and I have a -6x, but they're not on the same side of the equation. So I need to combine them, but I need to make sure that they're on the same side of the equal sign before I go ahead and do that. Right? And the same goes for my constant terms, this -7 and the 9. So it doesn't matter whether I move the x's to the left or to the right and the constants to the opposite of that. It just matters that I get them to the same side. So I'm going to go ahead and do that. So I see that I'm going to decide to move all my x's to the left-hand side. So let me see what I get when I do that. So my 2x was there first. But then I'm going to move my -6x to the other side, and that makes it a positive 6x. Okay. But also, so now I've dealt with that 6x, but also I want to get my negative 7 away from my variable term. So I'm going to move it to the other side here. And so my 9 is first. Now I move this negative 7 right here to the other side of the equation. I'm going to add it in. And now I'm ready to clean up. So, and as we just saw in the last question, I get 8x equals 16. And then by dividing out my 8 on each side, I'm going to get x is equal to 2. Okay, so this is a good example of where you might have variables that are on different sides of the equation. And I could have easily moved the x terms to the right-hand side, and that should have given me the same solution as we just saw. Okay, so this question is similar. It looks a little bit different, but it's here just to remind us to pay attention to our integers. I want you to try this on your own and then take a look at the solution to make sure that you're on the right track. All right. So I see that I have a negative 7y and I have a negative 10y. In order for me to combine those effectively, they need to be on the same side of my equation, same side of the equal sign. And so it just makes sense for me to want to keep the 12 where it is and not have to move it anywhere else. There is no other constant term. I'm going to leave my negative 12 on the left-hand side. My negative 10y is already on the right-hand side, so the only term I really need to move here is my negative 7y. And when I move it to the right-hand side, I'm going to change its sign to the opposite side. Now I'm ready to do some cleanup. So negative 10, I'm at negative 10, I'm going to add in 7. That's going to bring me to negative 3y rather. Okay? And again, double check your integers if you're unsure to make sure that you're actually performing the calculation properly. So I have negative 3y, and I want my y to be all by itself isolated on one side. So I'm going to undo this negative 3. And since negative 3 is being multiplied by y, I undo it by dividing out by negative 3. Whatever I do to one side, I do to the other side of my equation. And it doesn't matter that my y is on the right-hand side instead of the left. Most commonly in math, you'll see a proper formatted answer as having the variable on the left-hand side, but the solution is nonetheless good to go. All right, so I hope that those examples made sense to you and that will help you complete any work or maybe help you find some additional questions online or in your workbook. If not, please see me for some extra help if you happen to need it.